Welcome, class. Thank you for joining me for the beginning of Chapter 11. Now, this is really pre-Chapter 11. We are going to take a day to review your favorite concept of class so far, factoring, all right? Factoring is coming back again. It is going to be happening this entire chapter. So we are going to dedicate a day to making sure we recall how to do all of this factoring stuff. So our objective, to review factoring skills. I'm going to say factoring methods. Because if you recall, there are several different things that we have to take into account. Factoring is quite a broad term. So we're going to review all the different aspects of the word factoring. Now, the first way that we use factor, we can just mean pulling out a GCF, a greatest common factor. So if those are my instructions, if I'm thinking factoring as pulling out a GCF, remember that means I'm looking to see what divides every term. So in number 1, if I'm looking at the 4x squared plus 8x plus 12, what I'm noticing is a 4 pulls out of each of those. So if I take 4x squared and I'm dividing by 4, well, 4 divided by 4, I just get 1x squared. Next, I look at my 8x. Well, if I have 8x and I'm dividing by 4, well, 8 divided by 4 is 2. So we're going to have 2x. I look at the 12. 12 divided by 4 is going to leave me with 3. So that's our first method of factoring. Again, simply pulling out a greatest common factor. It's easiest when it's just a number. However, when you're looking, number 2, notice this is slightly different, okay? Notice in number 2, I want you to notice that we have our x in every term, okay? So because our x is in every term, that means we can pull out one of those x's. Again, you can pull out the lowest exponent that you see if it is in fact in every term. So in this one, I can pull out an x. And then once you recognize that that is what you're pulling out, now you do exactly the same thing. So we have our our x cubed. So I'm starting with 3, taking one of those away. So that brings me down to 2. I'll have an x squared. Our next term, we have negative 3. Then I have x squared, but remember, I'm pulling one of those out, so 2 take away that 1, just leaves me with x to the first. Then finally, our last term, we have 40. Then I'm starting with x to the first. I'm pulling out the only one that I've got there, so the x actually just disappears. And then number 3. Number 3, if we're looking to factor out a greatest common factor, between 14 and 7, well, what divides both 14 and 7? Well, I see that a 7 divides both of those. We have n squared and n to the first. So again, our variable is in every term. So that's telling me that variable can be pulled out. So you can pull out an n to the first from each of those. And now we play the same game. I start with a 14x squared. I'm dividing out 7n. So 14 divided by 7 leaves me 2. N squared, and I'm pulling out n to the first. 2, I'm taking 1 away, leaves me with an n to the first. 7n to the first. So 7 divided by 7 leaves me a 1 there. Now, n to the first, I'm taking away the only n that's there, so that means it is gone. And that is what we have left. All right, so those first 3 examples, again, that is reviewing the skill of simply pulling out a greatest common factor. Now, another skill of factoring is difference of squares. So remember, for difference of squares, we're looking for 2 perfect squares being subtracted. Now remember, by perfect squares, what we're looking for, even powers on variables, so even exponents, or in terms of numbers, we're looking for things like 1, 4, 9, 16, 25, 36, so on and so forth. All of those perfect squares. Those are the things that we are trying to identify. So in number 4, notice we have two terms, they're being subtracted, and notice that 4x squared is a perfect square number and a variable with an even power. 4 breaks down into 2's, x squared breaks down into x's. 9 is 3 times 3. So I've broken both of the perfect squares down. And what do we do from there? Remember, these are the ones that we get that plus and minus relationship. So I build that structure right away. So then I don't make any mistakes when I'm putting in 2x plus 3, 2x minus 3. Difference of squares always has that plus and minus relationship. All right, number 5. So again, looking at the numbers, 49 and 36, that is our first clue. Because we know 49 is 7's. Then m squared, well, you guys are good at this now, is m and m. So I found the square root of that 49m squared. 36 is 6 and 6. So again, two perfect squares being subtracted. So that means I really do have this difference of squares pattern. So I build my structure, that plus or minus, 7m plus 6, 7m minus 6. And then we're done. Number 6, we're looking at the same thing. 9 and 25. That's kind of our first clue. We're talking about perfect squares, and they're being subtracted. So 9 breaks down into 3 and 3, and then the x's are there to make the x squared. 25, the square root of that is 5. So again, I have that structure. So I build my parentheses, and now I just fill it in. 3x plus 5 and 3x minus 5. All right, so moving right along. Now, these next ones, 7, 8, and 9, these are the ones where we're factoring a quadratic trinomial. So when we're factoring a quadratic trinomial, remember that's when we started just by building those parentheses. All right? So then I had to think to myself, x squared, where did the x squared come from? Well, that comes from the first two terms, which in this case have to be x's. Then I look at that negative 6. All right, that negative 6 can come from 1 and 6, 2 and 3. However, to multiply to be a negative means one of the numbers in our list has to be negative. So, now remember, this is the case where a is 1. The x squared is by itself. So remember, in these instances, it really is as simple as picking now from those 4 which ones will add to give you that negative 5x. And if you look carefully, you should get the plus 1 and the minus 6. And again, we can check to make sure we've done it right. Make this connection. There's 1x. Make that connection, negative 6x. Yep, those add to negative 5x. So building the next one. Again, when we're dealing with quadratic trinomials, we're going to start with our parentheses. And now I'm going to analyze that x squared. Well, that comes from x and x. That 16 comes from 1 and 16, 2 and 8, 4 and 4. All right. And this is one of the simple cases where that a value is 1. The x squared is completely by itself. So that means we really are looking for two numbers that multiply to 16, which I've already listed out, and then add to that 8. So which two add to 8 here? Well, plus 4 and plus 4. And again, let's check to make sure this worked. 4x, 4x, yep, that did add to the 8x that I was looking for. Now, this is kind of a special case. So if you remember to do so, that x plus 4 times x plus 4, really since you have two of the same thing multiplying itself, you could just write that as x plus 4 squared. I won't jack you points if you don't, but it's a little bit cleaner way to write it if you're interested. So, number 9. Let's get our parentheses ready. So this n squared is coming from n times n. This 32 is coming from either 1 and 32, 2 and 16, 4 and 8. So now, once again, this is one of our nice cases where that a value is just 1, the square term is completely by itself. So we really are just looking for what adds to 32 or multiplies to 32 and adds to negative 18. Okay, so now what we need to do is think, how are we going to add to a negative number? Okay, so how can we multiply to positive, add to negative? Well, the answer to that is both numbers are going to be negative. Okay, so here I'm going to be putting in two negative numbers. What adds to negative 18? Well, if I put in negative 2, negative 16, that should give it to me. So I'm going to check this out. I'm going to check my work. Negative 2n, negative 16n. That does add up to the negative 18n. So I've done this one right. So moving right along. So what happens when they get more complicated? All right. What happens when now the a, or the square term, is not by itself? A is not equal to 1. But we're going to start exactly the same way. So I think to myself, where did that 2x squared come from? Because this time it's not x and x. This time is going to have to be 2x and x. And then I have to think to myself, where did the negative 6 come from? Well, how do we get 6? Well, 1 and 6, 2 and 3. Note the fact that it's negative. So in the end, we know one of those numbers is going to be negative. So I'm just going to start plopping in numbers, seeing what I can get. So I'm going to put 1 and 6 in there. All right. And I'm going to see what happens. So there I get 1x. There I get 12x. Now remember, we already discussed one of those has to be negative. So making one of those negative either gives me 11x or negative 11x. Is not giving me the 1x that I'm looking for. So this can't be my combination. So remember, that's where we now reverse them. 6 and 1. Let's see if that turns out any better. So here we have 6x and 2x. So making one of those negative, I'm either getting 4x or negative 4x. Either way, not what I'm looking for. So that must mean it's not the 1 and the 6 combination. So let's jump to the next combo here. All right, let's try the 2 and the 3. Make my connections. 2x, 6x. That's going to give me 4x or negative 4x. Still not what I'm looking for. So That must mean I have to reverse these, give this one last shot. So I'm going to put the 3 here, the 2 here. This time notice I'm getting 3x, 4x. Now here's the combination. When I make one of these negative, I can get the positive 1x that I'm looking for. If I make the 3x negative, that is how I can get the positive 1x, and that is going to be my solution. So remember, it can be quite a bit of work. It's fitting together a puzzle. However, once you get good at fitting them together, it's completely doable. So number 11. So I think to myself, how did I get that 3x squared? 3x and x. How about the 5? Where did the 5 come from? Well, there's only one combination that gives you that, the 1 and 5. So this one you can already tell right off the bat, it's not going to be that much work. Plug in my 1 and 5. Let's see if that worked. 1x, 15x, and yes, that gave me the 16x that I'm looking for, so that means that is my answer. And for our last one there, now this one is a little bit unique because when I make my parentheses here and I'm trying to figure out where did the 4x squared come from? Well, the 4x squared could either come from 4x and x or 2x and 2x. There's two possibilities of where this could come from. So what that means is we have a lot more checking that we are going to have to do. So once we get that set up, now we have to start looking at the negative 15. So where does 15 come from? Well, 1 and 15, 3 and 5. Now, this is where number sense comes in, okay? We have a lot of options to juggle. Not only do we have our two structures, but then we have those to deal with as well. So I'm going to begin looking at the 2x, 2x1. All right. Oh, I did not write that very well. Now, again, once you get good at working with some number sense, it gets easier. So for example, if I'm using 2x and 2x, probably 1 and 15 is not going to give me the option that I'm looking for because 15 is an awfully large number. So I'm probably better off trying the 3 and the 5. All right? So let's see what happens there. So I'm getting 6x and 10x. Now keep in mind that is a negative 15. So one of those is going to have to be negative. So in making one of those negative, can I get to negative 4x? I can. If I make the 10 be negative, which correlates to that negative 5, positive 3, that gives me exactly what I need. So again, what this all comes down to is simply fitting together the pieces of a puzzle. Okay? So thank you for joining me for this review. So once you're done taking all these notes, please make sure that you bring this packet to class and so we can continue with our practice work.